Hello everyone. My name is Gursheen Kaur, and today I'll be speaking about Frappe Slides, and the topic is building slide interactions. So, this is basically my journey of adding basic interactions into Frappe Slides and what I learned through doing that. So, a little bit of context for understanding what goes on into the slide canvas when you look at the slide. So when you see a slide, what components do you see? You see the elements, that is the text, the media, and videos, etc. Another thing is how they interact with each other. So each of these elements have certain interactions with other elements on the slide. They have interactions with the slide itself, and they basically move, resize, and all these interactions take place when you build the slide. And the third thing that binds all of this together is the actual canvas and how the properties of the canvas affect both of the previous two, that is the elements and the interactions. So these include scale properties and translate or transforms that are applied on the parent canvas. So when you're making a presentation or when you're creating a slide, the first thing that you expect to do is place an element at a specific location. So the very first thing that I wanted to build was adding basic dragging functionality to the elements. And if you try to imagine and break down the problem for understanding how dragging would work, you would imagine that there is some kind of parent element. There is another smaller element inside it, which is the actual text or media, and you want to move it with the cursor of the user. So such a visualization I've put here. You can see that the bigger element is kind of a reference to the slide itself, and the smaller square that you see is the element that I want to drag on the slide. So when you actually drag an element, what you basically do is place your cursor on the element and move your mouse. And when this movement occurs, the position of the element changes relative to the cursor that is moving. So in order to calculate how much that movement or how much the position should change, you would want to track it using the previous cursor position and the current cursor position. So everywhere that you see dragging elements, this is how it is calculated. The previous cursor position on the x as well as the y axis is tracked, and it is compared to the current cursor position on both of these axes, and the displacement is calculated so that the element can move along with the cursor. So if you put it into pseudocode, in a broader level perspective, this is what exactly you would imagine to happen. There is some previous position that is set for an element, that is the left and the top positions. And when you move the cursor, there should be some displacement on the x as well as the y axis. So this addition is made for the new position to be calculated. Okay, so in order to better understand this, I've created somewhat of a stripped down version of what actually goes on into Frappe Slides, and let's look into that. So this is the parent element that you can imagine to be the slide, and this is a smaller div for representing the element on the slide. Now there is no functionality that I've added here, but I want to make the slide element to be draggable. So like I told you before, every time I move the mouse, there should be some displacement on the x as well as the y axis. So like I mentioned in the pseudocode, I'll add the functionality to this particular div. So the code for that slide container as well as the element that you saw on the screen is here. And this is the parent div. I've set basic width and height, and this is the element. And how the position is currently getting applied is using a dynamic style. So even if you don't know Vue, this is how you would apply it in HTML, CSS. You would set the left and the top properties for the element, and that is some sort of initial value, and then you would change it with the movement. So currently there is no dragging functionality, but if I were to add a dragging event, then I would want to trigger it using the mouse down event like I told you before. So when you start dragging, when you want to drag this element, when you start dragging, it should happen when I move my cursor on the element and I use the mouse down event, and then I use the mouse move events. So the start dragging should occur when mouse down happens. So let's see how start dragging handles changes of the element position, and this logic I've written in a separate composable, which we can see here. So as you would imagine, there is some initial position that is set on the element, that is the x and the y position that I told you before. And I would want to set some basic boolean to know whether currently the element is getting dragged or not. One way where you can use this boolean is to change the cursor of the element. So for example, I want to show a separate cursor for the element when it is dragging. So I can use that here. If the cursor is currently dragging, that is the boolean is set, then I want to add the cursor as move, otherwise the default cursor. So after setting the initial properties, now I want to track the mouse move event, and with every mouse move, I want to update the left and the top positions. So for doing this, like I told you before, the current position on the x and the y axis you can get from the event itself using the client x and client y values, and I have already stored the previous x and y values, and I just want to subtract both of them to find the movement. I've added basic console logs to explain how this takes place when I move the cursor. So let me just clear. Okay, so when I start the mouse move event, as you can see on the right hand side, there is some movement on x and y axis, and the previous position is used, and both of these are added to get the new position. So after I drop it, the position remains the same. So this is like basic dragging that is added. Okay, so after you add basic dragging to the slide element, when you're building a slide, you want to place the elements on specific positions, and there should be some layouts on the slide. And the most common layout is placing the elements or the text right at the center. So for the user, there should be some visual feedback that there is a slide center that you can go to, or this is the slide center, so that you can understand where exactly the user has to move. So in order to show that, I've added alignment guides to the slide. And how this would work is I would want to know whether the current position that I get after dragging, whether that is close to or within the proximity of the center, whether that is the vertical center or the horizontal center. And I want to compare both of them, and there should be some kind of basic threshold that is set, crossing which the guide will be visible. So if the element is far away from the center, then the guide won't be visible, otherwise it would be visible. So in order to do that, I set a basic threshold for the proximity. So in the example, I've taken an arbitrary value which is 15 pixels, and whenever the center of the element crosses this threshold, the visibility for the vertical guide is set to true. Now this is just telling me that I want to show some visual feedback on the slide, and I can add a component which can use this Boolean value to show up or disappear the particular guide. And so this is the map that tracks whether I want to show or hide guides on the vertical as well as the horizontal axis. And like I told you before, the proximity threshold to compare how much or when the guide will be visible. So let's go back to our Let's go back to our stripped down version, the demo. And after adding drag, I want to add basic guides. So other than the template that I showed you earlier, I've added a new component, and it's nothing but a div that adds lines to the vertical and the horizontal center. And the important thing to note here is it will set the display property of both the vertical and horizontal centers depending upon the visibility map that I showed you earlier. So it would hide and show the center guides. Now, how do I generate this visibility map? Like I told you, I want to compare it with every drag moment. So I've added the functionality for it here. And I would set some initial values for storing the differences between the center of the element and the center of the slide. And I would then set it to true, that is the value to true if the arbitrary threshold is crossed. So how do I determine where the center of the element lies and where the center of the slide lies? This is just a basic calculation. If you want to find out the center of any element that you see on the screen, it's just left value added with the half of the width. So I'm basically just doing that here. I'm calculating the slide center using the same formula and the element center and finding out the difference to store it inside my variable, that is this. Okay, so now that I have stored the difference and I've set the visibility map depending on that. Okay, another thing that I forgot to mention is how this is set. So computed values basically let you change the value of the particular map depending upon the variables that you see here. So every time the difference, the vertical and the horizontal difference changes, this map will be updated automatically. And my new value will be set for whether I want to show or hide the guides. So after I do that, I expose this variable from my utility to my template and and this is getting consumed by the guides component that I showed you earlier. So every time now I move the element close to the center, the guide shows up, and similar to the vertical side, the horizontal side as well. So now that we've added some basic feedback, like visual feedback of where the slide center actually lies. As a user, you expect the element to automatically align to that position. You don't want to do it manually. So there should be some snapping that takes place when you cross the threshold, that is, you cross the proximity threshold for this, and the element should automatically snap to that position. So that logic will be handled like this. So I am already tracking whether the center of the element has crossed the threshold. And I can use this to now set a variable that I want to trigger the snap. And the snap is essentially just essentially just adding the X and Y snap movements to the total movement of the element. So after I have snapped, I would expect the element center to completely align with the center of the slide. And like I told you before, this is measured exactly how I calculate the other values. I want to track the difference and find out whether it is under a particular threshold, and then add that difference to automatically change the current position to the position of the slide center. Now this is a very naive approach, and I did try out this approach and I got some results. You can see it here. So as you can notice, there is some movement when I go to the center, and the element basically bounces back from the opposite side to my original position, and it is not very smooth. It is basically jittery. And another thing that you notice that I showed was this. So when I move from the extreme left of the slide to the extreme right, there is some resistance that is applied. So considering that I don't want to snap to the center at all, I just want the element to move from one side to the other, there is unnecessary resistance that is applied in the middle, and I don't want that. So to solve this problem, we would want to approach it in a manner of understanding how the problem is actually getting caused. So what is happening here is, when I add the threshold exists on both the sides, since the element could be approaching from the left as well as the right. So when the element crosses the threshold from one side and snaps to the center, and the user is in the momentum of moving it towards the center, it quickly snaps away from the center and goes to the other side. And on the other side, the logic for snapping is the same, since it is symmetrical. So it bounces back to the center. And I don't want that. I want free movement beyond the other side. I just want it to snap when I'm approaching the center. And the other thing that I mentioned, moving from far left to far right, the resistance that is applied is like unnecessary. I wouldn't want that. So as you can see, compared to the actual position of the element, the threshold is too much, like the amount of area that triggers the snap is large. So in order to solve that problem, I somehow want to reduce the effective surface area which would cause the snap or trigger the snap. So let's move to how we would solve this problem using both of these causes. So if I essentially reduce the surface area from either sides and limit it to a smaller area, then I can still add the snapping functionality. And additionally, I want to track if the element is currently moving away from the center. So I would want to track the previous difference from the center and compare it to the current difference. And if that difference is depending upon that difference, I would set the moving away value. So in this example, if I'm moving towards the center and the element center is currently within the threshold, then the snapping value will set to true. But the element is not moving away from the center because the previous difference is greater than the current difference. So I would want to apply the snap in this case. And if I'm moving away, that is, if the element has crossed that threshold and moved to the other side, then I don't want to apply the snap, even though can snap is true. That is, the snap should technically trigger. So I want free movement on the other side. So the logic that I explained to you in the visualization earlier is basically that I am tracking with an arbitrary value here, that is 3 pixels on either sides, and also tracking whether the element is moving away from the center. And if both of these conditions are met, only then I'm applying the snap movement. So with the current approach, if I move the element to the center, then it snaps and there is no resistance that is applied on the other side. And if I'm moving the element between left and right, there is almost negligible resistance. So in the actual, I'm still continuing, bear me for 5 more minutes. So in the actual demo, I would add this functionality and show you. So I'm adding the total snap movement here, and it gets calculated in my earlier utility like I told you before. So the conditions that I showed you in the pseudocode, I've added them in code here, and depending on those conditions, I'm setting the snap movement here and then snapping to the current position. Although you saw this in the video that I showed you before, there is another problem that I am facing now. When I add this logic and snap to the center, the element quickly snaps and moves away from the center because there is not much delay that is applied here. I removed any resistance from the other side, so the user doesn't get a feedback that the snap actually occurred, and the user has to stay on that position. So I would want to introduce some sort of delay so that the user understands that the snap occurred and this is the exact center. So in order to solve that problem, I just have to set a basic timer. This could be a different value, but for now I've set 400 ms. And if the snap occurred in the specific threshold, like the time, then I don't want to allow any further movement for that specific time, and then re-enable all the other movements, that is the drag movements, and this value is getting used here. So every time I move the element, I check whether the movement is disabled or not by the snap, and if it is not disabled, then I want to add the movement to the total element position, otherwise I don't. So after doing this, I just get proper feedback that the snap occurred, and similar on the other side. So now I'm finally done. Thank you.